In less than 2 years, the cost of labor inside local warehouses, hospitals, and homes is projected to just 40 cents an hour. For decades, humanoid robots remained confined to the lab as expensive research experiments. Machines like DARPA's early Atlas models were bulky, tethered to power cables, and required entire teams of researchers just to maintain basic balance. That physical barrier collapsed when engineers combined the learning capacity of advanced neural networks with the high torque power of custom electric actuators. This timeline chart tracks humanoid robotics progress over the last 70 years. Progress remained nearly flat from the 1950s until this point right here, where the line shoots straight up, marking 2025 as the start of industrial mass production. Manufacturing lines are now scaling a completely new, infinitely flexible global workforce designed for real-world deployment. You can see this mechanical transition in Boston Dynamics' latest Atlas model. They retired the heavy hydraulic systems that defined previous generations in favor of a fully electric platform. This design ignores the biological limits of the human spine. If rotating its waist a full 360 degrees is the most efficient way to grab a box behind it, the robot simply spins its torso backward without moving its feet. Achieving this level of agility required custom high-powered electric actuators and a skeletal structure utilizing 3D printed titanium and aluminum for a superior strength-to-weight ratio. With the hardware barriers resolved, the competitive advantage in robotics now rests entirely on the sophistication of the machine's mind. That mental leap relies on artificial general intelligence, or AGI. AGI is the ability to learn and adapt to any intellectual task a human can do, a goal now being prioritized by companies like Sanctuary AI and Figure. This illustrates Sanctuary AI's carbon architecture. A single model absorbs natural language and environmental data, outputting physical action paths. This eliminates coding individual movements. Instead, a fluid neural network adapts the robot to unstructured environments like kitchens or factory floors. These machines also utilize fleet learning through the cloud. When one robot masters a new physical task, like handling a specific automotive part, every other robot in the global network instantly acquires that exact skill. These robots refine their movements through continuous feedback loops, much like the YouTube algorithm learns from your interaction. You can help feed that algorithm right now by hitting the like button and subscribing to the channel. Because millions of units share a collective cognitive network, these machines are accumulating physical intelligence at an exponential rate that biological humans cannot match. The industry is now racing toward commercial scale. Tesla's third-generation Optimus features a sleek, consumer-ready casing and an aggressive price target of just $20,000 per unit. Other firms are disrupting the ownership model entirely. Figure plans to lease their general-purpose humanoids for roughly $300 a month, less than 40 cents an hour for a machine that never needs a break. To meet demand, manufacturers are initiating recursive production, deploying their own humanoid robots onto assembly lines to help build the next generation of robots. When robots begin building more robots, the global supply of labor is no longer tied to human population growth. Production capacity begins to scale infinitely. This rollout has already moved past the prototype stage. Initial deployments are active in automotive plants, where humanoids from Boston Dynamics and Figure are already moving parts for BMW and Hyundai. These structured factory floors into massive logistics centers, hazardous mining operations, and eventually into consumer homes as healthcare assistants and caretakers. This intersection marks the shift into an autonomous economy. As the supply of available robot labor hours spikes, the cost of consumer goods, which is largely driven by the price of human labor, begins a steep decline. Near-free labor removes the primary expense from manufacturing, construction, and daily services, pushing the global economy toward a state where physical effort is no longer a bottleneck for production. Automating the dull, dirty, and dangerous roles that have defined physical work for millennia provides a path toward permanently removing that drudgery from the human experience. The global economic transition is already underway, and the new workforce is clocking in for its first shift.